Hello everybody, this is Edgar Eddie Fernandez, your safety coach 4.0, and I want to share the flammable and combustible liquid handling course. I'm going to make this course in a different way. Um, um, I, uh, I designed some case studies for to learn better how to handle and storage flammable and combustible liquids. Okay, we start. It's an overview. What is a flammable liquid in general? Well, flammable liquid is a substance that can ignite easily and burn rapidly. That's the quick definition. And they can be common materials that are most work sites, for example, in gas, in liquids, or solids. So, in addition, flammable materials may also represent a health hazard as well. So, an example could be a toluene, for example, or methanol. Those two flammable liquids they have health hazards as well. Yeah, as part of their nature. This webinar actually will cover only flammable combustible liquids handling and storage, and I'll try to cover OSHA and NFPA standards as well that govern the handling and storage of these liquids. For the Canadian market, touch a little bit of the I live in Ontario, Canada, so near to Toronto. So I cover the Ontario Fire Code. Section 3, actually, that is flammable and combustible liquids. Currently, flammable and combustible liquids are used in the pharmaceutical, chemical, and other industries in different part of the process. Could be during the cleaning, could be during the process, or in maintenance as well. What are the objectives of this webinar? Is to design a safety program for flammable and combustible liquids, understand the different precautions for handling and storage of flammable liquids, and understand the hazards that the flammable liquids pose to workers, and understand the requirements to NFPA flammable and combustible liquids. The training, and review safety practices for the Chemical Center of Process Safety. Under the American Institute of Chemical Engineers, they have some, I would say, guidelines for this type of chemical substances, and we're going to see communication. Well, what is the definition of what is a flammable liquid? According to the NFPA 30, the Ontario Fire Code, and it says that a flammable liquid is any liquid having a flash point below 30.7 degrees Celsius or 100 Fahrenheit. The flash point is the lowest temperature at which a liquid gives off enough vapor to form a flammable mixture with the air. What is a combustible liquid? What is any liquid having a flash point at or above 100 degrees Celsius or 37.7 degrees Celsius, and 100 above 100 degrees Fahrenheit. We have a classification of this type of liquids. Normally, the general classification is flammable and combustible liquids. And also, there are these two classes or these two classifications that they are following the flash point. So you classify these liquids according to the flash point, and this is important to know. And you can know it on your MSDSs or SDSs now. And because the quantity of flammable combustible liquids can be stored at any location is determined by the class of the liquid. So it's very important the type of the classification of these liquids that you have in your facility or organization. We will see the classification of flammable liquids. You have class 1A, so it's liquids having flash point below 23 degrees Celsius or 73 Fahrenheit and having a boiling point below 30.7 degrees Celsius or 100 Fahrenheit. Class 1B, the class 1A could be your gasoline, actually, is one of them. Most of the non-conductive flammable liquids are in the class 1A, toluene, gasoline, those ones. It's the type of liquids you're going to find in this classification. Excuse me. Class 1B is liquids having flash points below 23 degrees Celsius, 73 Fahrenheit, and having a boiling point at or above 30.7 degrees Fahrenheit, Celsius, sorry, or 100 degrees Fahrenheit. Class 1C, liquids having have a flash point at or above 20 degrees Celsius, 70 degrees Fahrenheit, or below 30.7 degrees Celsius or 100 Fahrenheit. That's your classification of flammable liquid. And the combustible liquids, actually they classify, they are class 1, 2, 3A and 3B. So the 2, it's liquids with flash point at or above 100 degrees Fahrenheit or below 140 Fahrenheit. Class 3, liquids with flash point at or above 140 Fahrenheit. Class 3A, those with flash points at or above 140 Fahrenheit or below 200 Fahrenheit. And class 3B, those with flash points at or above 200 Fahrenheit. That's a classification. It's very important that you have it in mind, these two charts, the flammable and combustible liquids, because that's going to determine as I said, it's going to determine the maximum quantities to store in your warehouse or at any determined location. Definitions to consider is what is a non-conductive flammable liquid, especially if you are in the pharmaceutical industry or chemical industry. So it's non-conductive liquids. They don't dissipate the static much, and they do it more slowly, and therefore pose an increased risk of static accumulation. So static accumulation flammable liquids include, for example, the naphtha, the cyclohexane, the N-ethane, benzene, toluene, and hexane, xylene, ethylbenzene, and styrene. Those are the type of liquids that are non-conductive. That is one is the most dangerous in the you have it in your process or stored in your facility, and normally these type of liquids they are 1A. Another one, it's static electricity. You can find actually on NFPA 77 how NFPA is standard, how they regulate static electricity. Some of the regulations in the OSHA, actually the flammable combustible liquid regulation in OSHA mentioned that the standard as well. The NFPA 30 and NFPA 77, and in Canada, if I remember correctly, as well. So there is a good practices there to dissipate static electricity while handling these type of liquids. So what is a static electricity? It's an imbalance of electrical charge with on the surface of the material. The charge remains until it is able to move away by means of an electric current or electric discharge. Vapor pressure is a measure of liquid propensity to evaporate. That's another parameter, and actually the non-conductive liquids, they have a high vapor pressure. So it's another parameter you need to consider, especially in your operation. You are in the chemical during the chemical reactions or inside of the reactors is something that you need to consider as well. Now we're gonna start with the case of the study. Actually, it's one we start from shipping and receiving until the end of the process. So the disclaimer here is the information contained in these study cases are based only on study cases examples for teaching purposes. The information of these study cases are both factual and fictional. Opinions formulated by the author are intended to stimulate class discussions. Like I said, the overall process of liquids in a facility, in any chemical or pharmaceutical facility, is receiving, storage, production, and waste. We start with case A. So company A received 10,000 liters of toluene in the following means of containers: totes, drums, and pails. During the unloading, the supervisor noticed that 2 totes are leaking and the forklift operator is operating in a non-rated forklift truck. Also, the supervisor realized there are 2 drums with materials that are not used to be on the facility. Recommendations of case A. So remember, so we receive in a different means of containment in totes, pails, and drums. Two of them, they are materials that we are not using in the facility, and we are not using a non-rated forklift. Okay, so all the workers involved with flammable liquids in the shipping and receiving area shall have training in transport of dangerous goods, Canada, or DOT in the US. The forklift should be EE rated to transport this type of liquids according to the NFPA 70. Now, here can come, or somebody can say, that is not necessary because we have a well ventilated area. That depends in what you mean. If you are complying with that, yeah, you can argue that. But my recommendation to avoid going, that's going to be the next step of this. It's going to the red level room with a non-rated forklift that is going to cause trouble. So use the EE rated to transport this type of liquids according to the NFPA 70. To contain spills during the unloading operation, the loading dock shall have a secondary containment area to collect the spills to prevent cross-contamination to other areas or sewers, according to the EPA 40 CFR Part 68. And in Canada, the same with the E2 regulation from the Minister of Environment. Case V. Now, we have a bull tank truck that arrives to the facility with 20,000 liters of methanol. The truck drives towards the tank farm area, and a shipping and receiver specialist will proceed to unload the chemical. During the unloading, he noticed a sparking tube in two places, at the pump and at the end of the hose. At the end of the unloading, the specialist noticed that he hooked the hose in the wrong tank. Therefore, 25,000 liters of toluene were contaminated with methanol. Something that I forgot to mention on the last case, one recommendation, and actually something that you should compare as a shipping and receiving specialist, as the reason why you're specialists in the shipping and receiving area, they need to be trained on the transport of dangerous goods, because the first thing that they need to do is to check the PO, the purchase order, against to the bill of lading. So that's the thing that they need to do first. And if the PO and the bill they don't concord, you don't start unloading the vehicle or the totes, pails, and drums. As is the same with the bull tank truck. So first thing, actually, before they start unloading all the stuff, you need to compare the PO against the bill of lading, and if they don't concord, you don't unload. That's it, simple. So recommendations for case B. Obviously, it's going to be grounding and bounding. Rate the hose according to the API American Petroleum Institute 300. Ground the pump. And APF 30 recommends to use brass pumps instead of stainless steels. So that means in case of fire, you want the brass pumps, they don't melt. And designing the procedures according to the API 2003 protection against ignitions. So that's the recommendations for case B. And this is a schematic to unload tank trucks or cars, how to ground and bound. And actually there is technology outside on the grounding and bounding systems that that you don't is not, if the system is not grounded, it's not allowed, the pump doesn't start. So that is a good system to have it, and it's common to find it on the industry in both industries nowadays. And this is how the electrical components on that, they should be rated according to the NFPA 30 and NFPA 70. So there you have the class 1, D1 now, class 2, class 1, D2, And now it's zones. Actually, that's the new one: class 1 zone 1, class 1 zone 2, class 1 zone 0, class 2 zone 1. That's the NFPA 70 classify the electrical components according to the or what type of flammable liquid you have. That's the reason why the classification is very important. So recommendations for case B. So pump shall be according to the API 14F regarding on design and installation maintenance of electrical systems for oil and offshore industry. The NFPA 70 signage of according to the Global Harmonization System GHS. Case C. So from case A, the flammable liquids coming in totes, drums, and pails will be stored in the area called red label room. During the operation, the supervisor of the area noticed the following: the forklift is not rated, there is a drum open inside of the room, and a smell of a mix of flammable liquids detected, and ventilation was off, and 3 tons of corrosive material was mixed with drums of flammable liquids. What we need to do? The forklift needs to be EE rated. That's the reason why when we start reviewing case A, since the beginning, and in your procedure, I recommend that you guys state that the EE rated forklift needs to be operated since the beginning, because if not, you have a non-rated equipment going inside of the red level room, and then occurrences can happen. Ventilation. You need to have a mechanical, exhaust, and natural ventilation. These 3 types of ventilations you need to have on your red label room. Provide ventilation in case of a power outage. So that's the reason why you have natural. So that means that the panels on ventilation, they open when you have shortcuts or you have a power outage. So they open and then they allow the natural ventilation come inside, go in and out. Set up operational procedures to manage the red label room. The room shall be classified as class 1 zone 2, therefore no transfer and open containers are forbidden. Therefore the transfer and open containers are forbidden in this space. So that means we're not allowed. Signage, eye wash, and shower station needs to be provided, and explosion-proof panels according to the fire code. Emergency exit, shut off the switch outside of the room. Engineer the spill containment system to manage and control the spill from the red label room. PPE, the storage of flammable and combustible liquids from production or maintenance departments. The static dissipation practices, fire protection, and racking and storage as well. Safety containers. So containers should be tight sealed when not in use. Approved safety cans are recommended for smaller quantities. That's the type of containers that need to be on your red label room. We jump to case D. In the area CDE of Plan E, an incident occurred. An operator was filling a drum with a non-conductive solvent. The solvent was supplied from one of the tank farms to the area CDE. Also, the drum was 5 meters below the supply point of areas CDE. The outcome of the incident was a flash fire inside of the drum, and the flame came out following the operator in the shower station. So that means when I say drum was 5 meters below, that means they have a hose on the top and they bring it 5 meters down to the drum to start filling that empty drum. What are the recommendations from case D? Is establishing the grounding and bounding procedures, engineer the process to dissipate the static, get the following data: minimum ignition energy. That is very important. Normally, a good practice to have is to get the minimum ignition energy data for flammable liquids, evaporation rate, and relaxation time. So, because that's gonna tell you what is the minimal voltage that you need to have to start an ignition. So, and then you design your static dissipation systems based on that number. Do not fill solvents into any insulation plastic drums or cans other than a small container capacity less than 5 liters. That's NFPA 30, and it's mandatory in OSHA and it's mandatory in Canada according to the fire codes as well. So you cannot use plastic drums with flammable liquids. That's against the regulation. So here actually I show you the flammable liquid limitations in gallons and the type of containers that we have. So you guys will, that's the reason why, keep in mind, use the tables that I use, that I present you on at the beginning: flammable liquids classification, combustible liquids classification, and then you have here, you have the container, you have the type of containers, and you have the classification of the liquids and the limitation of what the quantity limitations on each one of the on the, according to the type of the container. So that's I use this table as well to be in compliance and not having any incident that can occur in the future, because has happened before. The same on combustible liquid limitations, you have the type of container, the material that was built, and the classification of the liquid. Recommendations for case B: avoid the splashing phenomena inside of the drum by using the deep tube same length as the container, because having the splashing, actually you have more vapor generation of the flammable liquid, and also it's hard to dissipate the static. So and actually the NFPA 30 has the flow rate, maximum flow rate that you need to use. Let me see if I put it here. No, I think it's 4 liters per minute, something like that. It's very slow, and you can find that data. Don't use the data that I'm telling you right now. Go to the NFPA 70 and the 70, excuse me, NFPA 30, and you're gonna find the flow, the maximum flow to load this time the means of containment. It's very slow and it's to control the dissipation of static, especially on the non-conductive liquids. So we jump to case E. Company H has a chemical process that uses 1,000 liters of heptane, 500 liters of solvent DFG as part of the process. The heptane is transferred from the tank farm area to a 5-liter glass reactor located in area GHE. The solvent DFG is transferred for 2,000-liter metal drums. At the end of the process, the maintenance department conducted an internal inspection of the vessel, and they found that there are holes in the glass line reactor. Therefore, they called a supplier to search more expertise to find a root cause of it. The root cause of the hole is due to the static generation during the filling and agitation of the solvent during the process. Casey, many fluids actually handling operations can generate static. This becomes a problem when the non-conductive pipes, glass or Teflon line are used without adequate bounding. So now you have a glass line reactor that should be grounded and bounded. What are the recommendations for case E? No splashing filling. So you need to go to NF530 and see what is the type, what is the flow, the maximum flow rate that is allowed. I don't have the data, sorry for now, but you can find it on NF530. Second, you need to find out the limit oxygen concentration that you need to have inside of the reactor. We know that on combustible powders, and I'm using this comment only for reference, and I'm not telling you that is the right data, because it depends on each flammable liquid. But in the combustible powders, normally is no more than 12%. And then you need to go, if you're gonna design the system, and you're gonna measure the oxygen according to the NFPA 68. You need to go 40%, and you don't have oxygen detection, you need to go 60% below the LOC. 68 applies for The same for flammable liquids, but the LOC for flammable liquids is very, very low. Some they have 6%, some others they have 4%. And one of the cases here, actually, with the oxygen, in this case, that you have a high oxygen concentration. You are inert for sure, but you need to make sure that you are below the LOC of the flammable liquid, and 40% if you have oxygen detection system, and 60% if not, to avoid this type of phenomena. Deep legs to reduce a splash filling phenomena. So you need to design your reactor in the same way. You have an agitator. That's something that maybe could be difficult, but other recommendations like following the NFPA 30, the maximum flow rate can help. Grounding glass line vessels. So how you you're gonna say how I do that? Well, according to the expertise for the manufacturer of these reactors, actually they during the building of this reactor they they insert a tantalum. It's a patch actually, tantalum patch that you can ground it actually to your ground system, and then now your reactor is gonna be grounded and you can start dissipating static or metal props, but the easiest way actually is to pad to have the pad the insert of tantalum, and then you can ground from there. Remember there is another drum, so ground the drum and bound the hose to complete the circuit to dissipate the static when filling the reactor. So filling this schematic, put that schematic in your procedures as well. People need to be trained, by the way. Here I show you a fire triangle with the concentration is more. It's not as like the fire triangle with no data. Now you have here the data, so you need to have the lower explosive limit and the upper explosive limit, and then from there you have you know what is the oxygen concentration, and then also you're gonna know uh, you have the volumes and you have the nitrogen in percentage, so you know how much nitrogen you need to have inside of your system to inert. So how much oxygen do you need to start on a flash fire? How much nitrogen you need to inert? These type of triangles, they help you a lot to design those systems. If the vapor concentration is between LEL and UL, there is a serious risk of fire explosion. What are the training requirements? Well, general flammable and combustible liquids training program, you need to train your people on static elimination procedures, handling and storage procedures, general safety precautions such as smoking policy, PPE, etc. Specific safety precautions in area where flammable and combustible liquids are involved, emergency procedures, housekeeping. Now you need to include the global harmonized system as well. That should be part of your safety training for flammable and combustible liquids. Now, if you are on the PSN cover facility, this training needs to be renewed every 3 years. That's NFPA 30. OSHA regulations that for flammable and combustible liquids. Well, you have these regulations. It's different information. You have the 1910-106 that is this training is flammable and combustible liquids. But you have deep tanks and operations of deep tanks. You have the 1910-108. Process safety management of highly hazardous chemicals in the 1910.119, because now you need to review on the 1910-18. If you exceed certain amount of volume during the handling and storage, now you're gonna be governed. Your facility is gonna be under PSN or the process safety management system. That is the 1910-11.9. Hazardous waste operation or emergency response 1910-1.120. Other standards, you have NFPA 30, you have NFPA 70, 40 CFR Pi 68, the practice of equipment and process design from the American Institute of Chemical Engineers. There's a Control Center of Process Safety, and then Chemical Center of Process Safety, American Petroleum Institute Standards, and ASME as well. So the regulations that I show you on the last one, that they're applicable ones. Those regulations in Canada with the provincial fire code or federal fire code, they refer to these standards. Therefore, they are mandatory because the regulation is referring to these standards. Conclusion. In order to have a comprehensive program of handling and storage of flammable liquids, the following aspects shall be considered. Engineering practices to handle and store flammable liquids. Establish the process safety management program if the process and quantities meet the OSHA 1910.119 criteria. Determine the maintenance preventing programs for equipment which handle these solvents. Consider all the aspects of operations where flammable and combustible liquids are involved. Set a training program for all personnel involved with this type of operations. So in resume, if you review the PSM, the Process Safety Management Regulation, and you are above those quantities or you meet the criteria, now you need to set up a process safety management program. That now there are 20 elements. Any question, please? I'm Edgar Eddie Fernandez, your safety coach 4.0. You can contact me at Edgar Fernandez Safefficient@gmail.com, or on my telephone number is 613-464-0562. Or you can find me on LinkedIn as well on LinkedIn, www.linkedin.com/in/Safefficient. And also this training is going to be shared in YouTube, and Twitter and Facebook on my platforms. So therefore you have the description and links that you can where you can contact me. If you need to set up a PSN management program, procedures for the handling and storage flammable liquids, static dissipation, don't hesitate to contact me. I can help you to avoid any flash fires or any recurrence in your facility and be in compliance with the regulations that we mentioned in this webinar. Thank you very much and have an excellent day. Your Safety Coach 4.0, Edgar Eddie Fernandez. Bye.